Why does corrosion lead to dangerous fatigue cracks? Have you ever wondered why some materials fail unexpectedly, even when they seem perfectly fine? One of the main culprits is corrosion, and it plays a significant role in creating dangerous fatigue cracks. Let's break it down. Corrosion happens when a material, usually metal, reacts with its environment. This reaction can weaken the material over time. When combined with cyclic mechanical loading, which is the repeated application of stress, corrosion can accelerate the formation of cracks. These cracks can develop much faster than they would from fatigue alone. Fatigue cracks typically begin at points where stress is concentrated, like surface defects or inclusions. Corrosion makes these weak spots worse by creating pits or localized areas of material loss. These pits act like tiny notches that amplify stress, making it easier for cracks to start under repeated loading. There are several ways corrosion impacts fatigue cracks. First, there is anodic dissolution, where corrosion chemically removes metal atoms at the crack tip. This process advances the crack more quickly. Next, we have hydrogen embrittlement. Corrosion reactions can produce hydrogen atoms that seep into the metal. This makes the metal more brittle and susceptible to cracking. Another mechanism is film rupture and slip dissolution. Protective oxide films on metals can break down under cyclic stress. When this happens, fresh metal is exposed to corrosion, leading to repeated cycles of dissolution that promote crack growth. Corrosion tunneling and selective dissolution also play a role. Corrosion can preferentially attack certain phases or grain boundaries in the material. This creates pathways that make it easier for cracks to propagate. In a corrosive environment, cracks grow faster than in a non-corrosive one. Corrosion lowers the stress intensity needed for cracks to spread and increases their growth rates, especially at lower load levels. This means components can fail sooner than expected when exposed to both cyclic stresses and corrosive conditions. Corrosion fatigue is a common cause of failure in many engineering structures, including bridges, aircraft, pipelines, and marine equipment. To prevent these failures, it is essential to control both mechanical loading and environmental exposure. Some effective strategies include using corrosion-resistant materials, applying protective coatings, controlling environmental conditions, and designing components to minimize stress concentrations. Understanding the interaction between corrosion and fatigue is vital. It highlights why corrosion is not just a surface issue but a significant factor in mechanical failures. This knowledge helps engineers design safer and longer-lasting products by addressing the combined effects of corrosion and cyclic loading.